So in our previous study of the univariate case, we learned that the curvature, namely convexity or concavity of the function, is directly tied to the sign of the second-order derivatives. So here, I would like to expand that discussion a little bit to the multivariate case. So basically, let us start with the review first. So in a univariate case, right, if a function is concave, that means it looks like a cave, right? So the first order derivative could be positive, right? To the left of the vertex, it is positive. To the right of the vertex, it's negative. Because now it's declining to the right. It was increasing to the left. All right. But then, in terms of second order derivative, the sign is consistent everywhere. Okay. So for instance, here you start with a very steep increase, and eventually it is a very mild increase. That implies that the first order derivative is decreasing, right? And now it starts with a pretty mild decrease and then a very rapid decrease. Then it also suggests that the first order derivative is decreasing. So the first order derivative is decreasing across. That implies that the second order derivative sign should be negative. The second order derivative being negative, that tells you the first order derivative is decreasing in x. So similarly, when it is convex, that's like a V shape, right? To the left of the vertex, f prime x is smaller than 0, right? The fx is decreasing in x. To the right of it, f prime x is greater than 0, to the right of vertex. But everywhere, the second order derivative should be greater than 0, because originally it was rapidly decreasing, like minus 1000, and now it is minus 5, right? The value of f prime x is increasing in x. To the right of vertex, it's similar. Originally, it was increasing mildly. Say f prime x equal to 2, the slope of the tangent line, which is the f prime x equal to 2. Now the slope of the tangent line is steep. F prime x equal to 1000, right? So f prime x is increasing in x across everything. So that suggests double prime, which is the second derivative, is greater than 0. So the second derivative being smaller than 0, that is to tell you it's a concave function, and there is a maximum, right, for this function. And the second order derivative being greater than 0, that is to say this function is convex, and there is a minimum point for this function. Okay, that's a review. So now let's look at the multivariate case. So in the multivariate case, as the shared screen is indicating, we still hold the same result. Say for the straight or direct second derivative, for the case where there is a relative maximum, namely there is a concavity, right? Then the straight second derivatives should be smaller than 0. This applies to x, second order derivative with respect to x, second order derivative with respect to y. For the case where there is a minimum, for a V shape or U shape, there is a minimum, there is the bottom, right, of the value. The second order derivative should be greater than 0 for a V-shaped function, for convex, right? That's where the V is. So the second order derivatives are positive for x and for y. Then for both functions, you should have the same result for cross term. which is the multiplication of the straight term should be greater than the multiplication of the cross term. So it is written here as fx by fyy greater than fxy squared. You may be confused, why is that? You can think about this being fxx by fyy greater than fxy by fyx. And since fxy and fyx are of the same value, that's why we just simply simplify this and put this as a square. So basically, that is to say the multiplication of two direct second derivatives should be greater than the multiplication of two cross derivatives. If all those conditions are met, then we can determine that this function is concave or convex. Namely, we can determine the curvature of this function. And we can determine whether there is a maximum for this function or minimum for this function. So now, let's look at the examples. For example 1, (1D), the curvature is on second derivative, right? fxx, fyy, fxy. So let's invoke the previous result. fxx here, fxx equals to -4, fyy equals to -16, fxy or fyx equals to 3. So let's check those conditions. fxx smaller than 0, fyy smaller than 0, and fxx by fyy is -4 by -16. Those two minus signs are canceled, and the result is 64. Whereas fxy squared, or is fxy by fyx, that equals to 9, and fxx by fyy minus fxy squared is greater than 0. So here we can switch to check the conditions in the table, which will be provided to you during the exam. And here we can see fxx is -4 smaller than 0, fyy is -16 smaller than 0, and then fxx by fyy is greater than fxy squared. So the result is that this function is concave, and there is a maximum for this function. This function is like this case. So now let's turn to the second one, 2D. So here it is marginal, the utility function, x1 squared, x2 to the power 6, marginal utility 1, 1, marginal utility 2, 2, marginal utility 2, 1, or 1, 2, which is the same. So let's refer to the previous result. Marginal utility 1, 1 is 2 times of x2 to the power 6. Marginal utility 2, 2 is 30, x1 squared, x2 to the power 4. And the marginal utility of 2, 1 is 12, x1, x2 to the power 5. Okay, so now the first one is supposed to be positive. The second one is supposed to be positive. Why is that? Because any function to a power which is even should be non-negative. And here, x1 and x2, those are amount of goods, which should be positive numbers, right? Like in this case, it is 2 times of x2 third to the power 3 squared. Anything squared is non-negative, right? And especially when these are positive, then it's squared, it's definitely positive. So then what we need to determine is mu11 by mu22. What is the result? 2x to 2 to the power of 6 by 30, x1 to the power square, x2 to the power of 4. And here that is 60 by x1 to the power of 2. And here by x2 to the power of 6. And x2 to the power of 4. Right? So x to the power of a by x to the power of b equals to x to the power of a plus b. Just a little calculation rule applied here. So the result is 60x1 squared, x2 to the power of 6 plus 4, which is 60x1 squared, x2 to the power of 10. Okay, so that's the multiplication of the two direct terms. Then the squared of the cross term gives you the result of 12 squared x1 x2 to the power of 5 squared, and x a to the power of b equals to x to the power of ab. So here 12 squared is 144, then x to the power of 2 squared, that's x squared. I'm sorry, x1 squared, right? And x2 to the power of 5 squared, which is 144 by x1 squared, x2 to the power of 10. So here it is 60 x1 squared, x2 to the power of 10, and this is 144 x1 squared, x2 to the power of 10. Then mu11 by mu22 is smaller than mu21 squared. And here, if you look at the condition, you can see this condition, the second derivative, including cross term, the condition at the bottom is violated. Therefore, this one, the utility function, is not concave nor convex. And there is no maximum nor minimum for this case. So here is the result. Thank you.